Dopamine is first released from a vesicle from the presynaptic neuron, while the postsynaptic neuron receives the ligand. The axion terminal contains many vesicles that are filled with these ligands. When an electrical signal excites the presynaptic neuron, the transmitters are released from the vesicles into the synaptic cleft through a dopamine transport where it links and binds onto the postsynaptic neuron receptors on the dendrites. There are two types of receptors for dopamine, D1-like and D2-like. D1-like consists of the D1 and D5 receptors, which stimulate the activity of adenylyl cyclase, while D2-like, consisting of D2, D3, and D4, inhibit it.
After the dopamine binds, the D1-like receptor allows a G protein to be released which attaches to adenyl cyclase. Once activated, ATP is added and CAMP is produced, a secondary messenger molecule. CAMP in turn activates pKa that amplifies the signal response and activates the activity of other protein kinases until the cellular response is inhibited. Once pKa is activated, it begins to synthesize proteins, initiating Cav1. Cav1 allows for protein excitement, creating a loop. pKa also activates DARP32, which inhibits PP1 that prevents the protein loop from remaining excited. Once this cycle is completed, dopamine is allowed to return to the presynaptic neuron and return to its vesicles.